vector addition. Now I have written triangle law there. So let me explain. In the last video I had mentioned example of starting from point A here and 50 meter here to point B, correct? Then I travel let us say again 50 or no, okay, I'll take 100 meter here, 100 meter towards south. I'm traveling towards east, 50 meter, 100 meter towards south, and then I'm reaching this point C. Now what is my displacement? What is the change in my position from A to C? My displacement from A to B is 50, my displacement from B to C is 100, and my displacement, now if I start from my A as my if I take A as my starting point and C as my end point, then my displacement is going to be this, correct? A to C, and it would be root over 50 square plus 100 square, and that comes out to be something here. I don't want to calculate it right now, but then that is how I get my displacement, correct? Now what I did here, I'm going to make it a law. So what I'm going to do here is I start from my point A here, I reach point B. Now this A, it is called tail of my vector AB. So AB is one vector, my tail is A and head is B. Then my next vector is my first displacement was AB bar, my second displacement is going to be BC bar. Now here, B was head of vector AB and B is again tail of vector BC, and that gives me my vector AC, which is my resultant. So now how do we convert this whole thing into law? Now I have made this mathematical statement here, but then if I had to state the law, then I would state it as when we add two vectors, what we do is we connect tail of my first vector with head of my last vector, then that vector gives the resultant of the two component vectors. Here the component vectors are AB bar and BC bar, and AC bar is the resultant vector. So that's all about triangle law. But then can we generalize this triangle law? Yes, the answer is yes, because now what I'm going to do is I move from point C here. I started from A to B, B to C. From C I moved to point D. From D I moved here, E. From E I reached point F here. So now in this case, what is my resultant? I'll just remove this. What I'm going to do is I'm going to connect the tail of my first vector with head of my last vector, and then this gives me the resultant. This is R bar. I'm going to call it R bar. Okay, but then how does it really connect with my triangle law? What I'm going to do is I'm going to take pairs. Now my first pair is AB bar and BC bar, so I take resultant of that. Then I take my resultant of first two vectors and my next vector, and then I connect them, right? Then what I do, then I take the head of the resultant and the next vector, and I connect my starting with the ending. So tail of my first vector with head of my last vector, correct? And then I got this as my resultant of those vectors. And finally what I'm going to do is I'll just put it in red. This was my second last thing here. Let's say R2 bar. Okay. And now what I'm going to do is I'm going to connect tail of my R2 bar with head of EF bar, and that gives me my final result. So this could be termed as polygon law of vectorization. But then polygon law is not a single law, or it's not something which is separate from triangle law. It is a special case of triangle law. I'm just applying triangle law repetitively. So two laws, one triangle law and polygon law. In the next video we are going to talk about parallelogram law of vectorizations. Thank you so much.